Every single day, Americans toss out more than 28 million glass bottles into landfills. That's enough to fill a 10-story building from floor to ceiling. But here's the twist. Glass can be recycled infinitely without losing quality. Not once, not twice, forever. So how does a modern recycling facility transform mountains of discarded bottles into pristine new glass? What actually happens inside those massive industrial plants processing millions of bottles every week? Today, we're going inside one of North America's largest glass recycling operations. You'll see exactly how technology, chemistry, and human precision work together to give glass endless lives. We'll follow the complete journey from broken bottles arriving on trucks to purified material leaving for manufacturers. Let's get started. Picture this moment at dawn. A 40-ton truck backs up to the unloading bay and lifts its massive cargo bed skyward at a steep angle. Thousands of glass bottles cascade down in a thundering avalanche of green, brown, and clear glass. The sound is like a continuous explosion as bottles collide, shatter, and pile onto the concrete platform below. This facility receives between 80 and 100 truckloads exactly like this one every single day. That's roughly 400 tons of used glass, arriving before lunch even starts. Each truck dumps its entire load within 90 seconds, then pulls away as another truck immediately takes its place. The operation never stops during business hours. Front-end loaders with reinforced buckets immediately push the glass toward the first conveyor system. Hydraulic arms scoop up 2 tons per load and deposit the bottles onto wide industrial belts. The noise level here exceeds 95 decibels, requiring all workers to wear hearing protection at all times. Glass clinks and shatters constantly as bottles collide and break apart, even before processing officially begins. Some breakage is expected and actually helps with later crushing stages. Intake operators control the material flow using overhead cameras and remote joysticks from climate-controlled booths. They watch for contamination problems right from the start. Ceramic dishes damage crushing equipment. Large stones jam conveyor mechanisms. Metal caps and lids cause issues in optical sorters downstream. Human eyes catch the obvious problems before glass enters the automated line. One experienced operator manages 3 unloading bays simultaneously during peak morning hours, constantly scanning monitors and adjusting loader positions. The main conveyor belt rumbles to life with a deep mechanical groan, pulling glass upward at a steady 5 feet per second toward the first major processing challenge. But here's what most people don't realize about glass recycling. Different colored glass melts at slightly different temperatures and creates different final products with distinct properties. That's why what happens in the next stage determines whether this entire recycling run succeeds or fails completely. The mixed glass stream hits the optical sorting system traveling at 400 feet per minute on a wide conveyor belt. High-speed cameras scan every single piece using both infrared and visible light sensors working in tandem. The system identifies color in milliseconds through sophisticated image processing algorithms. Clear glass, green glass, brown glass, amber glass. Each type must travel to its own destination because even a 2% contamination rate makes the final batch unusable for premium bottle production. Precision air jets positioned every 6 inches along the conveyor fire controlled bursts that blast specific bottles sideways into separate collection chutes. Each jet fires with computer-calculated force based on bottle size and weight detected by the cameras. Light bottles need gentle puffs. Heavy wine bottles require stronger blasts. The timing must be perfect because bottles move past each jet station in fractions of a second. The accuracy rate exceeds 95% when the system runs properly. That means out of every 1,000 bottles passing through, fewer than 50 end up in the wrong color stream. The machine processes up to 15 tons per hour at full speed, which translates to roughly 50,000 individual bottles every 60 minutes. Quality control technicians patrol a raised walkway above the sorting line wearing safety harnesses. They adjust sensor sensitivity based on glass types coming through that particular day. Wine bottles have thicker walls than beer bottles. Jam jars have different shapes than soda bottles. The technician tweaks the programming in real time so the jets fire with exactly the right force. Here's a question for you. Does your city separate glass by color at the curb, or does it all go into one recycling bin? Drop a comment and let me know how your local system works. Now the separated glass streams disappear into enclosed tunnels. Each color faces its own gauntlet ahead because what looks clean on the outside hides surprising contamination on the inside. Brown glass bottles pour into the first washing chamber like a river of amber flowing downhill under gravity and conveyor pressure. Industrial spray jets positioned on all sides unleash water heated to 180 degrees Fahrenheit under 80 pounds of pressure per square inch. That's enough force to strip paint off walls. Labels dissolve and peel away in soggy clumps. Sticky residue from beer and soda washes clean. Food particles from condiment jars break loose and flush down perforated drainage grates. This intensive washing stage removes approximately 98% of organic contamination in just 90 seconds of exposure. The remaining 2% gets caught in later filtration stages. But water alone can't handle everything mixed in with the glass. Metal rings from bottle caps, plastic shrink-wrap labels, small stones that arrived with the original collection load. These materials flow into a secondary separation zone where powerful electromagnets pull out ferrous metals like steel caps. Eddy current separators use rapidly alternating magnetic fields to repel non-ferrous metals like aluminum. Density tables use carefully calibrated vibration and upward airflow to float lightweight plastic fragments away while heavier glass continues forward on the belt. Maintenance crews inspect the water filtration and recycling systems twice per shift. The facility recycles 85% of its water through settling tanks and multi-stage treatment loops. Fresh municipal water only replaces what evaporates or leaves with removed contaminants. One technician monitors pressure gauges, temperature readouts, and flow meters from a control room lined with screens, showing every washing station simultaneously. If pressure drops, it signals clogged nozzles. If temperature falls, it means heater elements need attention. The clean glass emerges dripping wet but remarkably pure compared to what entered minutes earlier. Yet it still looks exactly like recognizable bottles and jars. The part you can't see is coming next, and it's where the real transformation begins. The glass is about to be destroyed completely before it can be reborn into something new. The crusher roars like a mechanical beast as the first clean bottles drop into its steel jaws from an overhead hopper. Hardened steel hammers spinning at 900 revolutions per minute pulverize glass into fragments smaller than your thumbnail in violent impacts. The machine devours 20 tons of whole glass every single hour, reducing sturdy bottles into a granular material called cullet. That's the official industry term for crushed recycled glass that's ready for melting. The particle size matters enormously for what happens downstream. Too large and pieces won't melt evenly in furnaces. Too small, and you create dangerous respirable dust, plus excessive material loss through screening systems. Vibrating screens beneath the main crusher filter the cullet into three distinct size grades based on mesh openings. Coarse cullet measures between 1 and 2 inches across. Medium grade runs from half an inch to 1 inch. Fine cullet drops below half an inch. Each grade serves different manufacturing needs and commands different market prices. Fiberglass insulation manufacturers prefer fine cullet. New bottle production works best with medium-grade material. Decorative landscape glass and construction aggregate uses coarse pieces. Crusher operators stationed nearby wear heavy-duty hearing protection and safety glasses. They watch for unusual vibration patterns that signal worn hammers or failing bearings before catastrophic breakdowns occur. They change complete hammer assemblies every 400 operating hours because glass is incredibly abrasive and wears down even hardened tool steel. One set of hammers processes roughly 8,000 tons before reaching minimum thickness specifications and requiring replacement. The crushed cullet flows through magnetic separators one final time in a last-chance contamination removal step. Even tiny metal fragments missed in earlier washing stages get caught now, because when glass melts at extreme temperatures, any metal contamination creates permanent defects and weak spots. The purified cullet drops into tall storage silos, each holding up to 50 tons of color-sorted, cleaned, crushed glass, waiting for the next stage. But here's the twist most people never see. This cullet won't necessarily become bottles again. Where it goes depends on market demand and one absolutely critical transformation that happens next. 3. The cullet enters the furnace staging area where temperatures climb so high that all safety protocols require remote operation from shielded control rooms. Natural gas burners ignite in a carefully controlled sequence over several minutes, heating the main melting chamber to 2,600 degrees Fahrenheit. That's substantially hotter than flowing lava and hot enough to turn solid steel into liquid. At this extreme temperature, glass doesn't just soften or sag like warm plastic. It transforms completely into a glowing orange river that flows with the viscosity of honey mixed with pure light itself. The furnace structure is lined with specialized refractory bricks made from exotic ceramic materials engineered to withstand these punishing conditions. These bricks cost thousands of dollars each and require complete replacement every 3 to 5 years, as constant thermal expansion and contraction gradually degrades even these incredibly durable materials. Cullet feeds into the furnace through computer-controlled hoppers that maintain precise ratios measured to the pound. Pure recycled glass makes up 70 to 90% of the total batch mix, depending on final product requirements and customer specifications. The remaining 10 to 30% comes from virgin raw materials, including silica sand, soda ash, and limestone. These virgin additions adjust the chemical composition to meet exact industry specifications for strength, clarity, thermal resistance, and color consistency that customers demand. The furnace processes approximately 250 tons of total material every 24 hours, running continuously without stopping, because shutting down and restarting wastes enormous amounts of energy and risk cracking the expensive refractory lining from thermal shock. Furnace operators monitor everything from climate-controlled rooms equipped with infrared cameras, thermal sensors, and computerized control panels. They track 17 different parameters simultaneously, including melt temperature, glass viscosity, dissolved bubble content, and color consistency measurements. The molten glass sits in the furnace for 4 to 6 hours of critical residence time. This waiting period allows trapped air bubbles to rise slowly to the surface and escape. Heavier impurities that survived earlier, cleaning sink or float for removal. Convection currents from strategically positioned burners keep the molten glass in constant gentle motion, ensuring uniform temperature and chemical composition throughout the entire mass instead of creating problematic hot and cold zones. But before a single bottle or ton of cullet ships to customers, representative samples undergo a comprehensive battery of tests. Laboratory technicians extract molten glass directly from the furnace stream every 30 minutes using specialized long-handled ladles designed for extreme temperatures. They pour these samples into standardized molds and allow controlled cooling that simulates actual production conditions. Once solidified, rigorous testing protocols begin immediately. First comes detailed visual inspection under bright LED panel lights, positioned at multiple angles to reveal even subtle defects invisible under normal lighting. Trained eyes scan systematically for trapped air bubbles, unmelted particles called stones, unwanted color variations, or surface imperfections. Even microscopic defects get flagged and documented because they often indicate larger problems developing inside the furnace. Mechanical strength testing follows visual inspection. Sample bottles must withstand internal pressure from carbonation, thermal shock from hot filling operations, and impact forces during transportation and normal consumer handling. Hydraulic test equipment pressurizes bottles incrementally until they explode inside controlled chambers, revealing exact failure thresholds. Industry standards require bottles to handle at least 150 pounds per square inch of internal pressure. That's roughly 10 times what carbonated beverages actually generate, providing substantial safety margins. Chemical composition analysis uses expensive spectrometry equipment. Focused lasers vaporize microscopic glass samples, and sensitive detectors analyze the resulting light spectrum to identify every element present down to concentrations measured in parts per million. Too much iron oxide creates unwanted green tints in supposedly clear glass. Excess alumina makes glass prone to crystallization over time. The annealing tunnel provides continuous real-time inspection as newly formed products cool gradually. This tunnel stretches over 100 feet long and reduces glass temperature from 1,000 degrees down to safe room temperature over approximately 20 minutes. Cooling too rapidly locks in dangerous internal stresses that cause bottles to shatter spontaneously days or weeks later. Finished cullet and newly formed glass products converge in the massive shipping warehouse, where the recycling circle finally completes itself. Industrial forklifts navigate between towering pallets stacked 20 feet high, supporting Gaylord boxes filled with tons of sorted cullet. Each reinforced corrugated box holds approximately 3,000 pounds of crushed glass destined for bottle manufacturers, fiberglass insulation plants, decorative aggregate suppliers, or construction material companies located across North America. The warehouse operation ships between 40 and 60 full truckloads daily depending on seasonal demand fluctuations. That's roughly 800 to 1,200 tons of recycled glass leaving this single facility every day. Logistics coordinators manage an incredibly complex scheduling challenge requiring constant attention and quick problem-solving abilities. Bottle manufacturing plants need consistent daily deliveries to keep their massive glass furnaces continuously fed with steady cullet supplies. Missing even a single delivery window means production lines must shut down completely, costing manufacturing customers thousands of dollars per hour in lost output and idle workforce expenses. GPS tracking systems monitor every truck currently in transit with real-time position updates every few minutes. Automated alert systems notify coordinators immediately of traffic delays, mechanical breakdowns, or severe weather problems so they can quickly dispatch backup shipments or efficiently reroute trucks from other regional facilities. The shipping department employs sophisticated load optimization software that calculates the most efficient way to pack trucks based on weight distribution requirements, destination routes, fuel efficiency, and product fragility considerations. Glass is both extremely heavy and surprisingly fragile simultaneously, creating unique logistical challenges that other materials don't present. Too much weight concentrated on rear axles violates federal highway regulations and risks citations. Improper load securing allows cargo to shift during transport, potentially causing dangerous accidents or product damage. Quality assurance procedures continue even during the final loading process itself. Inspectors verify that cullet color purity remains within specifications by sampling random boxes before they ship, checking for cross-contamination that may have occurred during storage or handling. Moisture content gets measured using handheld meters because damp cullet causes dangerous steam explosions and serious quality problems in customer furnaces operating at extreme temperatures. Detailed documentation accompanies every shipment listing exact composition percentages, particle size distribution data, contamination test results, and full batch traceability codes. Customers rely on this technical data to program their melting equipment properly and maintain their own quality standards. Within days or weeks, this recycled glass melts again in customer furnaces, scattered across the manufacturing landscape. It becomes new bottles filled with craft beers, artisan sodas, gourmet condiments, and life-saving medications. It transforms into pink fiberglass insulation, reducing energy consumption in thousands of homes. It turns into sparkling decorative aggregates, beautifying residential and commercial landscaping projects. Some of these new bottles will return to this very facility months later, beginning the cycle again. The beer bottle you recycled last month might become the jar holding your pasta sauce next month. Workers here understand they're not just processing waste. They're operating a crucial node in a circular economy that reduces mining, saves energy, and proves that industrial systems can work in harmony with environmental responsibility. From collection trucks to sorting systems to crushing hammers to 2,600-degree furnaces, discarded bottles are reborn as valuable material ready for infinite lives. This process cuts carbon emissions by 25% compared to virgin glass production. Recycled cullet melts at lower temperatures, requiring less energy. This facility employs over 200 people in stable jobs while keeping glass out of landfills, where it would sit unchanged for a million years. The next time you finish a glass bottle, you're holding a choice. Trash makes waste. Recycling creates this remarkable journey. If you found this fascinating, hit like and subscribe for more industrial deep dives. Drop a comment. What manufacturing process should we explore next? Thanks for watching. Every bottle counts.